Hello, this is Esther and Kathy, and we're going to talk about our progress for our LFU for BaseJump STL project. So a quick overview of our project. Our goal is to develop an LFU algorithm for integration into BaseJump STL and for it to replace the current LRU algorithm for cache eviction.
Some of our progress so far, we talked about creating pseudocode for LFU logic and also the switching logic. We also synthesized some the BSG cache and analyzed it. And this week we're going to talk about the frequency matrix we created for LFU and our modified algorithm. And we're also going to talk about how we modified BSG cache. This is our original LFU algorithm. Basically is a queue, and the issue with the design was it wasn't saving the location, the ways or sets in the cache, and that's information that's important.
And so the way we decided to implement is by using a frequency matrix, which corresponds to the BSG cache. So when a new data is brought into the cache, we set its frequency to 1. And then we update the frequency by incrementing it on every hit of the cache. And then we clears the frequency when it's evicted. But this comes with a question of what should be the upper limit for the frequency, because we don't want this to go to infinity and some data might not be evicted and stay in the cache forever. So in order to address this problem, we decided to do a moving window, which we only consider the frequency of the elements in the window. In the example below, the size of the window is about 1K, and we are implementing this with a queue where we put the address of every request into the queue. And once the queue is full, we pop out one element per new request. And we set this popped frequency to 0, which means that this will get evicted. And this is a pseudocode of how we will find the eviction location. So we will pass the row of the targeted address, the whole row, including all the 8 sets. We will pass this array into this module that you see here. And then we basically take a for loop through each element in this array and then update the weight and minimum frequency as we go through the array.
Okay, so this is just like a block diagram of what we modified in BSG cache. We took out the BSG LRU pseudo tree algorithm module, and then we put in ours. And then we also wrote some RTL to update the frequency matrix synchronously because our LFU is purely combinational. So this is just kind of the hardware that we made in BSG cache. And this is like reset signal. It will initialize the matrix to all zeros. If these handshake signals are true, then we increment the frequency within the matrix. And if it's the first time we're encountering that location, then we set that frequency to 1 if these handshakes are true. And that is all for our progress this week. Thank you.